to lecture 33. Welcome to lecture 33.
Today I am going to explain, can we use pig iron also in EAF to produce steel. It is said that pig iron is also a good charge material or raw material to produce steel using electric arc furnace. How? Because if you see the islets of this pig iron point, it has high density and low melting point comparatively steel scrap, and carbon contribution is there. So carbon will be contribute to in the steel also. You can get carbon and no trace elements. Lot of impurities are removed at the stage of pig iron production only. And it must be, one need to notice that the EAF uses exclusively electric energy, but think about a situation that the pig iron has carbon content 3 to 4% and phosphorus, manganese and silicon and so on. This particular pig iron, if it is charged in EAF, it need to be refined further to reduce the carbon content, especially for refining the carbon content. For example, if you take in a proportion of this pig iron is in the form of hot metal 20%, which has average 3.5% of carbon, and 80% steel scrap with having 0.1%. For example, to produce 100 ton of steel with 0.1% of carbon using EAF by the combination of 80% steel scrap and 20% pig iron hot metal. So how do you compensate it? For that you need carbon to be removed around 640 kgs. This is also carbon mass balance. You can refer the problem of example A5 from the Dr. S.K. Datta textbook. You will be getting the clear idea of the calculation, and about the oxygen also, how much amount of oxygen need to be supplied to remove the carbon in the form of CO. So how do you do it? Those calculations help us to contribute to produce the better steel using EAF. Now think about those critical conditions, how much oxygen is required. If you need to oxidize Fe to FeO, Fe in the hot metal, and Si to SiO2, Mn to MnO, P to P2O5, you need more oxygen supply. But this particular point becomes less important in the case of if you are considering only carbon. Let us think about only carbon. For example, to increase more proportion of charges increased, you need to, that means that carbon is coming very high level, you need to supply more oxygen. Even 20% hot metal pig iron form is also required 630 meter cube of oxygen you required. So you need to compromise. It is advisable, if pig iron is increased, you need to supply more oxygen to convert this particular carbon into CO, so that carbon will be reduced. Finally, you can get the 0.1% of carbon, which was requirement as in one example. Extra decarbonization, even it take tap to tap time, you need to supply oxygen, you need to stop the electrode arcing. Once the molten metal is prepared, from the side tube you need to supply the oxygen and make it facilitate decarbonization. Then after tap into form of steel, that means it decreases the productivity. Obviously this particular CO form carbon is getting reduced, it decreases the productivity, but you will be getting the quality steel. One need to compromise about these situations. For example, practically in many of the private scale industries, they compromise using of pig iron hot metal. 30% is suggested, so that you will be getting the optimum results where you are using only electrical energy, and with the electrical energy the chemical reactions are sufficient enough to reduce the carbon content if it is 30%. But if you need to reduce the carbon content to such a 0.1%, you need to supply the separately the oxygen. Now this particular source of hot metal can be taken in the case of EAF steel production either from the blast furnace pig iron hot metal or smelt reduction process such as Corex hot metal, where you will find less of carbon compared to blast furnace. It is up to the choice. This particular hot metal is compared with the blast furnace unit and smelt reduction units. What is the final requirement of steel? If the blast furnace pig iron is having the less of carbon content, it is close approximate value, it can be chosen. Otherwise smelt reduction process. That is up to the production management administration will decide about those things. Now let me talk about if DRI or direct reduced iron or sponge iron is used as a raw material to produce the steel. What are the advantages? Can we replace this particular DRI with completely steel scrap, 80% steel scrap? Is it substitutable? And if need to be substitute, what are the things need to be compromised? One need to think about. You will be getting the answer for this question with the following points. For example, carbon content can be tailored in the output of steels, where production of EAF steel making, when you use the DRI as a raw material, can be done. That is a prime advantage of if we use DRI as a raw material. This particular DRI is having other name also, hot briquetted iron, and it is the emerging situation nowadays in the most of the electric arc furnace steel making. Can we replace the entire steel scrap with DRI, and can you remove entire the 20% of hot metal of pig iron? Can you use DRI? Was the biggest question. It is answered by using the selection of DRI. Now let us know how this particular DRI is produced. You need to know the history of DRI production process. Even it is a repetition. Already you have learned in this steel making process, iron making process. Now it is one need to emphasize on the main point. DRI especially is produced either by carbon from the coal as a reducing agent, or reformer gas, a combination of carbon monoxide and hydrogen as a reducing agent. DRI can be produced. It is named if you use gaseous reductant reformer gas, it is called hot briquetted iron, whereas coal reductant it is called direct reduced iron. This particular direct reduced iron has one more advantage, that there are no tramp elements, more impurities. Hence it is suggested that you can replace with the entire steel scrap, so that this particular tramp elements dilution will be very less in steel production by EAF if we use DRI as a raw material. And DRI should not be considered completely as a steel scrap substitute, because sometimes in the production a process of making the DRI, the carbon content may go high, and there may be some amount of trap elements may enter. So that is why some amount of steel scrap is suggestible to use, at least 20%. It is good that you can use DRI only to enhance the scrap charge instead of hot metal pig iron. For that it is definitely substitutable DRI, and steel scrap need to be reduced. And this particular DRI is having very high iron and less residual materials such as impurities, and it can also be used this particular DRI for the production of steel by using variety of furnaces such as induction furnace, resistance furnaces. Many are in practice in the industries. DRI can also be used as a form of cold DRI or directly mill scale hot DRI can be charged, which has 650 to 700 degrees Celsius temperature, or you can cool down to the room temperature. You can charge two things. If it is integrated steel plant with the DRI and EAF, you can use hot, and otherwise there is no chance of using hot. You need to be cooled down. Let us think about what all the things are there in DRI. DRI has the free iron, free carbon and oxygen combined with iron such as FeO, and few gang materials such as SiO2 and Al2O3 and P2O5. But here it is the quality of DRI is important. How much less carbon content is there, how much more iron content is there. This particular quality of DRI will judge the iron metallization, oxygen remained in the DRI. How do you calculate how much iron was there? By using metallization, the metallization is equal to free iron into 100 by total iron content from this particular composition. If by the calculation, if you are getting the higher metallization, it means you would require very less oxygen to remove this in the form of iron oxide during the steel making. So you no need to send the you no need to supply the extra oxygen. So directly that particular iron will remain in the steel. And what are the benefits of if we use DRI in EAF steel making? It has very low tramp elements, very less impurities, and it is good predictable uniform composition and all those things. It can also be predictable. You can balance the mass and heat balance, enthalpy and free energy balance, mass, raw material charge and output, how much charge was used and how much tonnage of steel is being produced. It is quite predictable, and carbon content can be tailored based as per the final requirement in the steel, and easy to handle than the steel scrap because of this particular. If it is in the hot metal hot DRI condition, it can be poured. Otherwise, if it is the steel scrap, there will be mix of steel scrap. The composition may not be uniform. If it is DRI, it will be uniform. That's why it is easier to handle. Can be continuously fed into the furnace, EAF furnace, to produce the steel, and it can also be charged if it is integrated steel plant hot charge, as I mentioned earlier. And better slag foaming, so you can reduce the carbon content further by slag foams. And nitrogen, good control of nitrogen is possible in the steel, because in the DRI production itself very less nitrogen was entered, and melt consistency and molten metal consistency uniformity is good condition. And it is one need to think about that. Mention whether this particular question is true or false. Pig iron can be used in the form of hot metal or solid form in case of integrated steel plant where DRI production and pig iron production and EAF steel making unit is there. So how do you do it? So whether it is true or not, please read some of the textbook, judge your statement. Thank you.